6, lesson 10, the last one for modeling sinusoidal functions. In previous lesson, we were asked to solve a problem where we were given the equation. Now we're going to be trying to get the equation. Okay? So here's the one we're looking at. It says, this wave shown as a maximum value of 50, a minimum value of 10. Write the equation of the sinusoidal wave in the form of the sine curve, with A being positive. So they're telling you A is positive. Okay? So a couple things to just kind of mark up. If A is positive, then that means it starts going up. Where does this one start? Going down. So that means it's shifted. It got moved over here because it starts going up. This is clearly the move line, like the half line, you could say. Okay? So they said the max and min was 50 and 10. What does that help me figure out? A and B. Amplitude, 50 divided by 10, or sorry, 50 minus 10 divided by 2 is 20. Your amplitude is 20. Right? If 50 is the high, 10 is the low, okay, that means that it's 40 across, so 20 is the amplitude. What's that? We always divide by 2. Max to min is all the way. Amplitude's only from the middle. Yeah. Well, you could if you know what the middle is. You know, but if you just know the max and min, which they gave you, you'd add the max min, divide by 2. That formula's in our notes. Okay, we did that. So A is 20. A is 20 is a positive 20, so it's greater than 0. Okay. Next thing I got to figure out is the period. So when does it repeat? So this is, again, what we were talking about earlier to start class. So this one starts at 16 and then goes all the way to 48. So it looks like the period is 32. Okay? So 32 is the period. So how can I write that in terms of my b, though? Because remember, it's in relation to 2 pi. Right. So that's where it's going to be essentially, you can do it 2 ways. I think it's actually easier to go, 2 pi divided by 32. So that's going to be pi over 16 is your b. Okay? So pi over 16 is b. Okay, what is your c? What is the phase shift? To here. Yep, just 16. C is 16. And then what's the vertical displacement? 30. We have everything we need. It's 16 because remember it says it's a positive A. So that means this is what it moved horizontally. It starts here. Goes up positive first. So our equation for this graph will be y equals 20 sine pi over 16 x minus 16 plus 30. That's your equation from that function using all the stuff we know how to do. Any questions on those? Any things we got? Right, but remember, so this is what we talked about to start class. We have a whole number period, but it happens in relation to 2 pi. So what that does, it makes our horizontal stretch a value with pi. It's going to have pi if it's a whole number, yes. Yes, if your period is like 20, the horizontal stretch or whatever is going to be in terms of pi. What's that? If the period's 3.3, like you counted, got 3.3, then yeah, you do. If it's 3.3, then you'd go 2 pi divided by 3.3, and that would be your b. Okay? All right. Okay, nail caught in a tread of a rotating tire at point N. So nail got hit in a tire. The following graph is showing the path of the nail as it's going around the tire. Okay? Makes sense? So the tire has a diameter of 50 centimeters and rotates at 10 revolutions per minute. Wow. Revolution, yeah. Okay, per minute. After 4.5 seconds, the nail touches the ground. So at 4.5 seconds to touch the ground, that's this location. Right? That's the nail hitting the ground. Okay? Use the information to write a scale for each axis. So the scale for the axis that makes sense, you want your y to be, I'd say my y would probably be 0 to 55, going by 5s, because the height of the tire is 50, so let's go a little bit above 50. My x, 10 revolutions per minute. So that means that I want to go, I'm doing my stuff in seconds, right? Yep. So I would say, yeah, I'd just say probably 0 to 12. 12 seconds. If I do 12 seconds, I'm going to hit them out 3 times. Do what? Remember, your scales, guys, chatter, your scales can be changed, and that's not an answer. You can put whatever scale that's best for you. Okay, I just did 0 to 12. That gives me about twice the tire's going to hit the ground. That's probably all I need to see. Determine the equation for the height of the nail as a function of time from h of t, a sine of bt, where a is positive. So they're saying a is positive. It's a sine graph. Okay, so the important part is this right here is essentially kind of the starting point. Okay. Okay. All right. So determine the equation. Let's just start simply. What is A? What is A? What's the amplitude? What's that? 25. Good. The reason it's 25, if you don't know, this whole thing's 50. That's the diameter of the tire. So 50 divided by 2, that's the amplitude of this curve. Okay, so good. Your amplitude is 25. Okay. What is the period? Well, it tells you this, right? 10 circles happen in a minute. So convert that to seconds. So how many revolutions a second? No. It's kind of simple, right? How many seconds in a minute? No, you times it. It's divide. So listen, if I have 10 times that tire makes a circle in a minute, then when does one circle happen? So you're going to do 60 seconds divided by 10. It happens every 6 seconds. The tire goes around. Okay? All right. So again, 10 revolutions happen in a minute. To figure out when one revolution is, that means go 60 seconds divided by 10. Because we know there's 10 revolutions in this time. So one revolution happens 6 seconds for one turn. One turn's a period, right? Because that's the rotation of the tire. So that means that your B is 6 seconds. Okay? Your period, not your B. Your period 6 seconds, we're going to write it as, we're going to write it as a B, which we'd go, right, 2 pi divided by 6, like we just talked about, okay, which is pi over 3. When we're talking in terms of radians. So like if we know that it's like, I'm trying to think. So think about beginning, right, where if our stretch is 1/2, we just do that to 2 pi, so then our period's in terms of pi. These periods are in terms of numbers. Does that make sense? So if we're talking about in terms of pi or in terms of radians, then your period is going to be a number. When your period's in terms of a number, your b is going to be in radians. So it's just kind of like they flip-flop in terms of how you explain them. Okay, so 2 pi over 6, so that means my period is simplified to pi over 3. Okay, so pi over 3. And then what is my displacement? What's my midline? 25, right? Okay, this tire is 50, halfway is 25. So that means we start up at 25. That's for the nail. Okay, so if you're saying, wait, it comes back down to 0, you're right, but they want to start here. So we do have to go plus 25. That's why I was confused on that too. They want to start where the nail currently just got hit in the tire, apparently. Okay? Yeah, D is 25. There's no C value, right. We're not going to shift it. Right. That's the part that I was confused on too, Ty. Yeah. So y equals 25 sine, and they tell you right here, Ty, because BT, they're not showing you there's a C. Like that. Okay. So what kind of helps me with this, understand it for me, is that let's just, for a second, let's just put 0 at time, right? Let's put 0 at time. If I put 0 at time, that's sine of 0. What's sine at 0? 0. What's 0 times 25? 0. Plus 25. So it puts me where I'm supposed to be. So you kind of check to make sure you're at the right location. And then it's going to go like this from there. Because we can still get sines -1, right? And we can still get like those values with the pi over 3. So just kind of keep that in mind. That's kind of where it comes from. Okay? And then part C, with that equation we just did, it says how far to the nearest tenth of a centimeter is the nail above the ground at 6.5 seconds. We're just trying to find the value at 6.5 seconds. So we simply plug 6.5 in and we calculate. So that's going to be 25 sine pi over 3, 6.5, and plus 25. Yes, you can do that trace as well, yep. 37.5 centimeters, which you should get either way. Okay, 37.5. Why that makes sense is because we know that we said that for our period, every 6 seconds it's hitting the ground, right? Or it's going a full turn. Okay, so let me show you here. I'll come back just a second. So this right here, it says it hits the ground at 4.5 seconds, right? But we know every 6 seconds it's going to go full around. So that means that's 10.5. I'm just trying to make you guys have number sense of why that answer makes sense. So 6.5, where's 6.5? Well, 4.5, 10.5, those are 4 apart. 6.5 is 2 from there. So that's right about here. So I mean, that's on an upswing. That's past halfway. You're almost at the top of the tire at that location in time. Okay, let me explain that again. They tell you in the problem 4.5 seconds when the nail hits the ground. Once it hits the ground, it starts the rotation going back to its high point, right? So 4.5, the nail's coming up. Okay, here's 10.5 is the next time it's hit the ground. 6.5, or is it 6.5? Yeah, 6.5 is right about here. So 37, this is 50. Okay, they're pretty close. So your number sense makes sense. All right, Ferris wheel, and we're done here. Did you need that down here still, Cassie? Did anybody need that? We're okay? Okay. All right, last question, guys, last question. All right, first Ferris wheel was built. The first one built was created by a builder named George W. Ferris. Real original, George. Okay, the diameter of the wheel was approximately 76 meters. The maximum height was 80 meters. The wheel had 36 carts on it. Approximately holds 60 people. It's just kind of information about the Ferris wheel. It's not really about our problem. Okay? The Ferris wheel was introduced to the World Fair in 1893 in Chicago. All this stuff is just stuff about a Ferris wheel in case you want to know. If the wheel rotated every 9 minutes, use the data in the table to sketch a sinusoidal graph that represents the height of a car in meters as a function of time in minutes. So we're going to try to sketch this here. All right. So we know from the table where, like how, the Ferris wheel obviously doesn't hit the ground. That'd be bad. So it's how high off the ground does it start? According to the table, where does it start? 4, but close. It says 0, 4 on the table. The table in the top right there. Yeah. So 0, 4, it's all right. We'll get there. So 0, 4 is where it starts. And then we know that 9 minutes is where it's going to get back to 4. So we know that that's kind of the path it's going to take. All right. And then we know that the high point is going to be halfway between those two. Okay. So 4.5 is going to be the high point, and that, they tell me that's at what? 80, right? So 80. So it's roughly going to look like that. Is going to be the sinusoidal curve that represents the tracking of the Ferris wheel. Okay, any questions on that? Okay, I'm going to go ahead and just pause the video. I want you to try to see if you can do B. See if you can get the equation. Take a couple minutes here. Talk to your partner if you need to. Okay, as we just talked about, before I had the video going here, so they tell you it's a cosine graph, so we're interested in the top point. The top point is essentially the starting point for cosine, so we do have a phase shift. It has shifted over 4.5 seconds, so we'll get to that here as they ask me. So let's go down here. So we know we're doing a cosine graph, it says. So let's just do, what did you guys get for A? 38. A is 38, correct. It's 80 minus 4 divided by 2. You get 38 for your amplitude. Okay, how about your period? The full curve happens in 9 minutes. So your period is going to be, how do you do it? 2 pi over 9, good. That doesn't reduce, so that's your period. 2 pi over 9, that's your B. Okay, and then we set our phase shift. We already got that. We said since it's a cosine curve, it's the movement of that peak, that top height. So it's going to be 4.5 right for 4.5 seconds. And what's our D? Which one? Horizontal phase shift would be pi. Why? Okay, in terms of a normal period, yes. But we put 4.5 because we're actually talking about seconds. Pi is not a time, right? You just keep the time. You just keep the shift that's there. I know what you're thinking. You're saying since it's halfway, that should be pi in terms of the direction around the unit circle. But we're talking in terms of time. So we stay in terms of time. But tell me a time when you wouldn't. Right? Because we're talking about shifts within the context of the problem. You're talking right in terms of how much, yes. Okay? All right. Sorry. Vertical displacement. So you can see that middle line moved, right? So you got to go, where's the center of that cosine graph? Well, the center is between 4 and 80, right? 4 and 80, so what's halfway between 4 and 80? So it's 38. We know that, right? But 38 is how much above the axis, though, because it's actually the value. You're right. So here, let me show you. We drew this graph, but it starts here at 4, right? We know that the amplitude's 38, but what's 4 plus 38? That gets me the half line. 42. So it's 38 is the length halfway between. You have to go that extra 4 to come to the ground. Okay? So what I'm saying is, you guys know this right here is 38. You told me this is your amplitude. But we have to go this extra 4 to come to the ground. So that's where the 42 comes from. So your D is 42. And your equation is ready now. So we have h of t equals 38 cosine 2 pi over 9 t right. So I want to go t minus 4.5. And then plus 42. Sorry, 42 is in the graph there, but plus 42. Questions? C, how high to the nearest meter is the cart at 5 minutes? Is the cart 5 minutes after the wheel starts rotating? So what do we do?
I just put 5 in, but I got a really high number for it.
Yeah. It's a little bit interesting because it's in, were we saying, gosh, last question was seconds. This is minutes. So these are in minutes, so you put 5 in. That's correct. I was saying seconds because the tire question was seconds. This one's in minutes. It says right here, time in minutes. So you just plug 5 in, guys. You put 5 in for t and calculate. So h of t is 38 cosine 2 pi over 9, 5 minus 4.5 plus 42. Calculate that. You should get 78 meters. Now, the reason, again, the number sense makes sense here. 5 minutes is really close to 4.5. 4.5 is the what? The highest spot for the Ferris wheel. Right? 4.5 is the high point. That's what it tells you. Okay? So 5 minutes is 78. That's really close to the high point. Okay? You just came over the, if you're at 5 minutes, you just went over the high point. You're on your way down. Okay? All right, how many seconds after the wheel starts rotating does the cart first reach 10 meters from the ground? Okay, so we're trying to find when it's 10. Okay. Oh, so that's where you can do the intersect. So you're going to put 10 for your y2. Yes, 10 here and solve for y, yeah. Okay, so there's 2 ways you can do it. You can solve for 10, or you can put y1, the equation we have, y2, you put 10 and do the intersect feature in your calculator. If you do the intersect feature, you will get 48.955. To figure out the actual seconds, you're going to do, oh, sorry, that's not right. That's the seconds. The first intersection is going to be x is 0.8159. You should get that for the intersection, sorry. Do that times 60 to get the minutes. So if you do that times 60 to get the minutes, it's going to happen at, or seconds, sorry. All right, so what this means is the first time that it's going to be 10, okay, is at 49 seconds. And that makes sense because you start at 4. You start here at 4 and you're on your way up. We know at 4.5 minutes it's the height, so quickly in almost a minute you're going to be at 10. So it's your track up. So that time makes sense. When you do the intersection, you get this for x. This stands for the number of minutes. So obviously that's not a whole minute. We're going to convert to seconds. So we times by 60 seconds to that decimal, and it gives me 48.89. So we round up to 49 because at 49 you'll be past 10. Okay, so that's where the 49 seconds comes from. Okay, all right, we are in.